Extraction and separation. How to extract caffeine from tea. First, place a 250 milliliter beaker on a hot plate and add about 150 milliliters of distilled water to the beaker. Open several tea bags and place them into the beaker. Place a watch glass over the beaker. This will help prevent the water from evaporating while it's heated to a boil. Remove from the hot plate once it has come to a boil and let cool. Macro scale extraction using a separatory funnel. First, add 20 milliliters of brewed tea to the funnel. Be sure that the stopcock is closed. You can make sure it's closed by making sure the hole in the plastic is about 90 degrees off from vertical. Here's what it looks like closed, and here's what it looks like open. To perform the extraction, we will need to use a solvent which the caffeine will be more soluble in than water, and will also have some other property to separate itself from the rest of the tea. If we look at the structure of caffeine, we can see why it's considered slightly soluble in water with its polar groups. We can increase its solubility in water by increasing the temperature, which is why we boiled the tea in the first place. We can also see by its structure that it will be soluble in certain organic solvents as well. Take a look at the structure for the organic solvent dichloromethane, or DCM for short, also known as methylene chloride, and compare it to water. Draw your own conclusions as to why we're going to use it for this extraction. Add 20 milliliters of dichloromethane to the funnel. Notice how the added solvent sinks to the bottom. Why do you think this is? Add a cap to the top of the funnel and gently shake to mix the two solvents. Turn the funnel over and slowly open the valve. As you can hear, shaking causes a buildup of pressure inside the funnel, and venting it allows the excess gases to escape. You may repeat this several times, which may lead to a higher final yield. Once you are satisfied, you can replace the funnel on the stand and wait for the layers to separate. This can take a few minutes, so be patient. If bubbles form between the layers, you can use a clean glass rod to pop the bubbles and speed the process up. Collect the bottom layer, which in this case is the organic layer, by opening the petcock and letting it drain into your collection vessel. You can collect it quickly at first, but be sure to slow down as the tea layer gets closer to the bottom. Repeat the extraction with DCM 1 to 2 more times, collecting into the same vessel that you collected in previously. Drying with anhydrous sodium sulfate. Even though we were careful when we were separating the organic and aqueous layers, some of the aqueous layer was transferred. In this case, it is these small bubbles of tea water floating around on the top. We can separate these by using a drying agent, in this case, sodium sulfate. Add a small, spatula-sized amount, and then swirl the flask, which will trap the remaining tea and bring it to the bottom. If necessary, you can add further small amounts to the flask until all the water has been contained. Next, you will transfer the dried material to another flask. To do this, standard gravity filtration will be used. Fold a piece of filter paper and slowly pour into the funnel. A glass rod can be used both to hold the filter paper down and to direct the flow into the funnel. Finally, in a hood, heat the DCM on a hot plate at a very low heat. DCM has a low boiling point and will boil quickly at a low heat. DCM is evaporated, the remaining caffeine will be left behind to form a crude solid. From here, it can be further purified.